Good morning. I am Karthik Chandrapati and this is my presentation on Lab 3. Introduction. In this lab session, we were required to analyze the motion of a star around a black hole and calculate the force that it experiences at various points in its trajectory. And one interesting result that I found through this experiment was that the distance is inversely proportional to the force acting between the star and the black hole. Physics principles apply. So the formulae I used in this case were the force between two celestial objects in space can be found using the formula F is equal to G is equal to capital G m1 m2 by r square. The centrifugal force acting on an object can be found using the formula centrifugal force equals mass into the square of velocity divided by the radius of the circle that the object is moving in, and that the momentum of a body is given by the formula P equals mv computational model. So in this case, what I did first was find the initial momentum of the star and find the final momentum of the star, and also find the change in velocity and the change in momentum. Using that, I was able to find the net force acting on the star. And through this, I also found out that the force that was acting on the star due to the black hole was around 7.015 into 10 to the power 28. And here, when we observe the diagram, we can clearly notice that it is going around in an elliptical path. And the results that I got from my code was the net force equals 7.609 into 10 to the power 28. The parallel force was 2.91 into 10 to the power 28, and the perpendicular force equals 7.015 into 10 to the power 28. So, what if? Is it possible to find the mass of a black hole that has replaced the existing black hole and has a different mass? I think the answer is yes. We can find the force that is acting on the star due to the black hole by observing changes in its motions. And by determining the force, we can substitute that in the formula G equals G m1 m2 by r square, and where m1 is the mass of the black hole, and we already know the mass of the star, the radius of the orbit, and the force acting on it. And through this, we can actually determine the mass of a new black hole. What does it mean? The net force, that is the sum of the centrifugal force and the gravitational pull of the star, remains around the same. It varies slightly, but it usually remains constant. Whereas the momentum of the star doesn't actually remain constant, and it changes with the position of the star at various instances of time. For example, when the star is very close to the black hole, the momentum actually increases so that it can escape the strong gravitational pull of the star and continue on its elliptical orbit. But as the distance between the star and the black hole increases, the velocity actually goes down a bit because it doesn't need to apply that much momentum in order to escape the velocity of the star. However, I think that the rate of change of momentum usually remains constant because there is a direct correlation between the momentum required and the distance between the star and the black hole. And through this, we can observe that the momentum actually changes in a gradual rate. Though the rate isn't constant, it increases and decreases at around the same rate. Thank you for your time and listening to my presentation.